In this video, we are going to sketch the graph of a polynomial function being given certain descriptors, but not enough specifics to warrant having a real XY coordinate system. So in this one, we are told that we have 5 roots. That means we have 5 zeros, which means we have at most 4 turning points. Say at most. It could have less depending on what we're given. But the rest of the problem tells us we have only one real root. And a real root is where it crosses the x-axis. Okay, so it's only going to cross one time. It also gives us the end behavior. Being that it has 5 roots, I know it's already an odd power, so the ends are going to point opposite directions, but this one tells me that as we go to the right, we go up. As we go to the left, we go down. So I need to have something that crosses the x-axis one time with at most 4 turning points. So there's going to be literally an infinite number of correct answers. I'm just going to start at the bottom left and work my way across. So I'm going to start going up. I'm going to have 1 turning point. Then I'm turn back up for a 2nd turning point. I'm going to turn down for a 3rd turning point, back up for a 4th turning point. That is 1 correct answer. I put all of my turning points before my real root. You could have put your real root first and all of your turning points after. You could have had some before the root, some after. Doesn't matter. I had 4 turning points. My ends are going opposite directions. That's my final answer. For the second one, this time they tell us we have 4 roots. That means 3 turning points at most. Then it also tells us the only real root is a double root. Double root means it's going to touch but not cross. The x-axis. Okay, so it's going to touch but not cross. And then we have end behavior. Since it's an even power, 4 roots tells me an even power, we are going to be pointing down in both directions. As the end behavior says, as we go to the right, we go down. As we go left, we go down. So 3 turning points. One of them is going to be where my real root is a double root, because a double root is going to turn around. It's going to go to the x-axis, touch, and then bounce back away from it. Okay, so I'm just going to pick a spot right here. It really doesn't make much of a difference. I'm going to start down here again. I'm going to go up to that point, and I'm going to bounce back down. That's one of my 3 turning points. It's also my real double root. So I can have 2 more turning points. I just can't go across that y-axis. So I'm going to make this into kind of a modified M shape. My ends are pointing down. I have 3 turning points. One of them is a double root because it touches right on the x-axis. If it had been a triple root, it would still kind of go through the x-axis. Any even-powered root, so double root, quadruple root, etc., was just going to touch the x-axis and bounce away. If it's an odd root, so like first, triple root, quintuple root, etc., you're going to slowly get closer to the x-axis and then go through it. Okay, that's multiplicity is the fancy word for that. You don't need to know that term, but if you want to look it up later, that is what that's talking about. So these questions are meant to be simpler than where I tell you it has a root at x is 5, a root at x is 12, whatever. It's meant to be simpler because you have more options, but I feel like that actually makes it more complicated because it's a little bit more open-ended, and there's not going to be one correct answer. You just have to make sure your answer fits all of the little pieces that it says it has to have. So in this case, 4 roots, 1 double root, and then the end behavior. The 4 roots implies 3 turning points. The 1 double root tells us that I only get to touch the x-axis. I don't get to cross the x-axis. Have a great day, everybody.